Well, good morning, good afternoon to you guys. It's my pleasure to be here again for your user meeting, albeit this time online. It's a shame we can't get together in person and face to face, but hopefully we can make that again next year. I'm going to do the usual hints and tips session. And again, as usual, I apologize that this is in English. So I'll take things nice and slowly and control myself to speak as slowly as possible. This year, I thought I'd do a session on welding actually and go into welding in a little bit more detail. We've got some great weld tools. Again, some of this is quite missed, and the requirement for welds in Tekla models and on drawings just gets more and more as each year goes by. So this presentation, if you've not seen me before, this is me here, the handsome chap. And again, we're going to cover Tekla welding in detail. And my name is Mick Hodgson, and I'm technical manager for Tekla in Finland for the steel segment. What I'm going to cover here is the actual welds within the model, not just your typical weld parts together. I'm going to look at the new weld types and tools, automated weld preparation, how we link down to machinery and the machinery that we support. I'm going to take a look as well at the drawings. Drawing output and how the welds are presented on drawings is very important, so I'm going to be taking a look at that. I might take a little look at as well into pipe-to-pipe welded connections and how we can put welds around pipe-to-pipe connected parts already. So we'll take a look at that. Anyone that's seen me before knows I'll be doing most of this live as well. So I'll briefly go through the PowerPoint and then we'll talk about how to do this live. And let me just get my phone out so I can keep checking the time. Okay, so modeling with accurate welds. Why do we do this? Obviously, as I explained at the beginning, the requirement for actual welds within the Tekla model grows week by week. We need to improve the quality of the weld reporting. That means that when you create a welding list, you get the correct volumes, weights, sizes of all the welds. We need to drive welding automation. So not just welding robots, but also coping machines. So actually putting in there the weld preparations. And with regards to weld preparations, we do have tools in there to help you with doing automated weld preparation of parts, which is quite a nice feature. We've improved, or we've added double-sided polygon welds and lots of new welding types. As you know, within Tekla, then what we have is we have the new toolbars in which to do this. Generally, most people just weld parts together, but there's some great little functions in here for creating welds in a nice, easy fashion. We've got the new weld types, including these two here, which are very important, the partial penetrations, and I'll be taking a look at those in detail. And then, of course, actually applying those and how they work within the model. One of the settings in here as well, and what we were asked to create at the very beginning, was we can jump from AISC standard weld and welding and weld functionality and welds on drawings or standard ISO. Now, I'll go into there and show you how we set that up and what the implications are for the welds. We've added, let me just move this little box out of the way just so I can see what I'm actually doing. These boxes on top of what I'm working on. There we go. So you can see then we've added the ability to put in double-sided welds with weld preparation, so fillet and with the weld preparation inbuilt into those. The ability to split welds into different weld parts. For example, here you can see rather than go all the way around the tube, I'm just doing a partial weld on the tube. So this is all nice commands and required stuff that's we've been asked for a long, long time. We also have quite a not a very well-known command actually, where you can actually draw the weld shape and define the weld shape yourself. We do occasionally have requirements where you have to define a special weld that's non-standard, and we now within here have the ability to draw any weld shape that we want, and I'll show you how we do that as well. Again, within here, automatic weld preparation. I'll do this live. So when you put the weld in there, it automatically cuts the part to suit the weld. Now we're going through all these in detail as well. You can see here as well why we actually model these, as I explained before, linking to CNC, not just for, as I said, not just for robotic welding, but also the marking of the piece on the steel itself, robotic assembly machines, and basic coping, even down to your basic drawing preparation details and things like that. So when I talk about coping robots, this is what I mean by a coping robot. So it's a machine that will read what we put in the Tekla model and cut the parts accordingly. So actually cut these pieces away, be it on the flange, in the web, wherever, and it doesn't matter what the size or shape of steel is, it will cut them in a three-dimensional way, but it can also apply, as you can see here on the top, the weld preparations as well. So it can automatically cut the weld preparations at the same time. So that's one of the reasons we actually put the welds in, to drive these coping robots. The layout of parts, these machines have been on the market a long time, where we can actually, as well as just cut and drill the steel, it will actually mark the position of incoming fittings. As well as that, it can also mark on the weld symbols. So in fact, what it does is it turns the piece of steel into a drawing. So rather than these weld symbols on the drawing, you can also actually mark these weld symbols on the piece of steel. So by putting these welds into the model, you can be sure then that it actually will, if you have the machinery or the capability, it will actually mark the steel up accordingly as well. Robotic welding, these are coming more and more now into the industry, where these automatic welding robots will weld the pieces exactly as they've been modeled within Tekla. So all this is welded. If this weld in Tekla was, let's say, from the middle of the plate to the outside, that's the weld it will put on. It reads exactly the information in the Tekla model and exactly replicates that on the actual piece of steel. And then, of course, we have the robotic assembly and welding, where it actually picks up the plates, fits them together, and welds them together. Full automated sort of robotic manufacturing of structural steel parts. Okay, enough of that. Let me go into the actual model itself. So let's take a look then. I've just got a simple model here, nothing glamorous. Typically, when people are welding parts together, they'll just pretty much say, go to the weld command here and say, weld that piece, welds to that piece. And that's generally what everyone will do. Just put a weld on there. The weld itself, if we click on it, let's just click on that weld, bring it up. Oops. There we are. You can see then that's a fillet weld of 6 millimeters. It's the usual stuff. This is nothing dramatic. And again, we can change that. One of the things you'll notice is when I click on the label, hopefully you can see that there, you actually get the marker on screen telling exactly, if you click on it, that is exactly what will appear on the drawing. And you notice there I've got a little marker afterwards, which is actually reference text. So I could put something like make was here. So if I change that, you'll notice then that actually appears on the weld marker. So if I go to this 6 millimeter weld here, change it to a 12 millimeter weld. And this is just the typical stuff that everyone does on a day-to-day basis. Nothing dramatic. But let's take a look at some of the other more advanced tools. So let's say I'm going to weld these two beams together. So what I'm going to do then is I'll say I want to weld. This time I'm going to say I want to create a polygon weld, which is really from point to point. So we're going to say, okay, let me just click on that button there. This part welds to this part, and the weld goes from this point here to this point here. And there you have the weld like so. If I click on the weld, I can then say to that weld, okay, it is a, let's say, simple V-butt, 12 millimeters, and the angle of it is, let's say, 40, in fact, 65 degrees. So it's a 65-degree angle. You can see that's there in position. You'll notice I've got the preparation set to none. That is the automatic weld preparation. I'll come back to that in a moment. Let me up this, let's say, to a 15 millimeter weld, like so. Let me put in the root face, which means what's the opening. So if I set a 2 millimeter gap, sorry, wrong one, it's the actual root opening at the bottom. There we are, 2 millimeter gap. You can see then I can open up and apply a gap into that weld. And then the length of that weld, we can say is, let's say, 20 millimeters long. So it can change and make the gap of the weld and the length of the weld. So that gives you the actual accurate weld weight and weld volumes from there. The next thing I can do is say preparation. So if I click on this weld here, and just click on it, bear with me, click out, click on the weld. Oops, where are we? I'm struggling picking the weld for some reason. Let's pick on the weld, there we are. And we can say then preparation is automatic. That means then it's going to automatically do the weld preparation to those two parts. And if I pick this weld up and drag it out, like so, pick that piece up, there we pick on that weld, there we are. And if I just drag it in slightly, you'll see, look, the piece has been prepared for the weld. So the part is automatically cut within the Tekla model. So every weld you put in there, actually now you can define the weld preparation automatically from it. So if I just repeat that, let's see at the bottom here, just go to the bottom, and again we'll say, right, let's do another weld. This time again it's a polygon weld, this one to this one. It remembers the weld I put in there last time. So if we draw that in, you can see that's the weld with the preparation. The leg, root face, everything is complete and ready. So nice simple way of doing that. If I come to the plate here on the top, I'm going to show you another new type of weld. In this case again, I'm going to say, well, in this case I'm going to say it's a weld, polygon weld, that beam welds to that plate, and I'm going to draw a weld from this point here to this point here, like so. You'll notice then I've got the same kind of weld. That's not correct for there. So I'm going to click on that weld, and I'm going to say, okay, it's a fillet weld of, let's say, 12 millimeters. Just turn that to nothing, and I'll modify that so you can see I've got a typical weld there, like so. And then I'll say the other side of that, I'd like the same kind of weld. And again, that's set to 0. That is a 12 millimeter weld the other side. Just click on that side. Just make sure I get this right. Click on the weld. So there, partial 12, like so. And again, a 65-degree angle, let's say, for that. I don't know if I got that right there. So that's the one, the other side, like so. You can see it's actually got the welds right, top and bottom again. So you can see the labeling's correct. Mick was here. Let's have this to be NDT, like so. And just click on the weld. There we are. And then what I'm going to say for the other side, the size is going to be 6 millimeters. And if I say modify that, you'll see it puts the weld then within here. Let me just turn off that root face to 0 and 0. So you can see now, look, I've put the weld preparation in there as well. So not only I've got the fillet weld this side, I've also got the root preparation the other side as well. And then I'll do it the other side. So we'll say 6 and 12 again. Modify that. You can see then I've got the welds both sides with not only the fillet weld on the outside, but also the penetration on the inside. And that's a new type of weld that we added. You can see there, that's all the information on that welding, like so. So it's a nice way of adding welds simply into the model. Nice, accurately, with full and complete weld preparations on there as well. So nice way of working on that. If I then say, okay, let's take a look at this angle that's welded to the top of the beam. Again, what I'll do is I'll just, in this case, I'll say it's a weld. That one welds to there, like so. Obviously, I've lost the solid because this weld is not correct. So let me just click on this weld. And what I'll do is I'll make this just a fillet weld, 6 millimeters all the way around. So if I modify that, there you can see it's the fillet weld. And in fact, that side should be set to none, like so. And then in this case, I will say it's going to be a staggered weld. So we can define as well the stagger. So it's hit and miss. So we can say, look, okay, it's going to be 200, miss 200. So this is then a staggered weld, like so. You can see there, look, we have the staggered weld. Easily set up like so. So what I've done, let me just repeat this. I've put in here a standard sort of penetration weld where I've defined the root opening. The preparation of the parts is automatic. I've put in here the staggered welds where I can put in the chain of staggers, what the length is, what the type is. And this is all, again, so if I download that to a welding robot, it will just weld these parts exactly as I've defined them in the Tekla model. On this piece here, I've put the welds in, but you can see as well as that, I've also defined the weld preparation on the piece of plate. So when I put that in there, using this new type of weld we've added, the partial penetration bevel butt weld, like so. That's also in there. And here I use just the traditional weld. Okay, so if I take a look at this one here, let me say now what I've got is I've got this pipe, it's welded to the underside of here, but I'd like half of it to be 6mm weld, the other half to be 12mm weld. That seems pretty odd, but it's sometimes a very typical thing to do. So again, I'll say weld, this piece here, this pipe's welded to it. You can see there I've got a partial weld on there around. Let me just click on that, change this. The reason it's partial at the moment is because it's set up to be staggered. And that's not what I mean. I'm going to say it needs to be continuous. So that's continuous weld all the way around. Now that weld, let me just change that so I can pick it up properly. There we are. That weld is one continuous weld. Okay, and I can't really manipulate it. So the first thing I need to do is I need to right click and say convert to a polygon weld. And what it does is that breaks it down into its individual segments. You see that? So now I've got these individual dots and parts. So in fact, I can move that weld to another position with its handles. But what I'm going to do here, if you go to the warehouse, we've got a set of welding tools. It's a welding toolbox. And this is a really functional set of welding tools that allow you to split welds, to join welds, to create very, very complex welds automatically to multiple pieces. So how does that work? Well, I've got this installed. When you install it, what you get is you get this new application here, welding tools. And what I'm going to say is I'm going to say, okay, let's split these welds. So here, double click on the split weld command. And I'm going to say I want to split this weld. Let's pick it up and I want to split it there. And then I'm going to say, okay, double click that again. I'm going to say split this weld and let's say split it this one here. And you'll notice then what I get is I get two separate welds split around those points. Well, actually three, because I did it by mistake. So I can say, okay, this one here, let's click on it. This weld, let's say, is going to be, click on that. That weld will have that as being 12mm in that position. This weld here will have it as being, let's say, 4mm. So that allows you then to have different parts split of these welds around these pipes. Seems very odd to do that, but you'll see that in multiple locations. And I'll give you another example of splitting these welds. Here, this is the one I put in earlier where I've got the weld all the way around. I use the typical weld command. So the first thing I'm going to do is I'm going to say split that, convert it to a polygon weld. That means it breaks it down into its handles. So again, I can reposition and move this weld now. So then again, go to the toolbox, split welds, and I'm going to say, okay, this weld here, split it there. This weld here, split it there. And then that top weld, I can click on that very top weld itself, just individually, double click on that and say, actually, that should be, let's say, 20mm fillet at the top. So those toolbox allow you to put welds on and very quickly manipulate them into the types that you're looking for. Now, of course, the main thing is that you need to create drawings of these parts and have them correct. So again, by clicking on these, you can see the label I see on screen is exactly the label you're going to see on the drawing. Okay. Now, I actually don't like working like this. What I like working with is actually welds as like actual welds visible on screen only. And there's several viewing options here. If I go to display, I can say welds. If I say fast, that means you just get the small ticks. I don't like that one bit. And then you've got here the welds. You can say exact, which means you get the solid weld on there. Just click on that, welds, exact. Just modify that. You can see you get the weld, the actual physical solid weld, and the little tick. Or you can say welds, I'd like exact with no weld mark, which pretty much means then if I just modify that, you get the actual, let me do that properly, exact, no weld mark, just change that, exact, go back, exact, no weld mark, modify that, there we go. So you can see then what I get is the actual welds with no ticks on them. That makes working on the model very simple and easy to do. And I like to work like that. That's the way I like to modify things. Again, let me just click on this and create a drawing of it. So drawing wise, drawing properties, assembly drawings. I've got one set up for welding where I've got the weld marks turned on. It's nothing special. So in this case, then I'll say create the drawing. It's an assembly drawing, number it, of course. And then go to the document manager, open that drawing up. There we are. So you can see then, if I just zoom in, got the welds there, the weld on the top, look, Mick was here, non-destructive testing on this one here, the actual length of the weld staggered, like so. Remember, hit 200, miss 200. There you are. You've got the sort of fillet at the top here, like so, with the angle, like so. And there, look, you've got the different length ones. So 6 millimeters, 12 and 4. So all that's through. But you'll notice as well that these parts, where are we, have been prepared as well. So automatically cut and prepared for the weld. See that? So when I put the welds in there, I haven't cut that beam. The welds automatically cut that beam for me. Let me just check this. I'm okay for time at the moment. One final thing I'll show you. In the welding toolbox, just come out here and let's take a look at this one here. So I've got, for example, these tubes connecting to these pipes, like so. The other nice command in this welding toolbox, the one from the warehouse, is if you go to modeling, modeling is actually create welds. So click on modeling here, and let me say I want to create a 12 millimeter fillet weld. There it is, like so. What we do is I want all these pipes to connect to these different tubes. So you say create, and we'll say this pipe here and this pipe here, and then the middle mouse button, I'd like this one, and this one to connect to them. And you'll see, look, that it puts the correct welds around those pieces. So that means using this toolbox, you can automate applying the welds into the models. You can see I've selected several at one point. It's done them all in one go. Another example of that would be here I've got a plate. And what I want to do is I want to weld all these beams on the underside to that plate. So in this case, what I can do again, I can say, look, I'm just going to do something general. It's 12 millimeters, create. So this plate here, middle mouse button, I'd like to connect that beam, that one, that one, that one. So select the ones you want, and then middle mouse button, and it will actually apply the welds, look, around those pieces in one go. So I can actually select multiple parts and get to automatically weld them. Oh, can you see that? Okay, there we are. I'll zoom in a little bit more. You can see then how they're created automatically based on that. Like so. One last thing before I finish. You can as well, I'm a big user of the mini toolbar. You can see the mini toolbar. Every time I talk to people, I always refer to the mini toolbar. So on here as well, you can still change directly the size of welds. So I've changed that to a 20. You can make that into a sight weld, say, for example, simply. You can say, okay, what's the size of the angle, things like that, and other options as well. So even the type of weld. So I could say just it's a general one, like so. So I should change that again at the top, wrong one actually. So just go up. There we are, just a simple one like so. When you've set that up, we can then double click on that. You can say, I want to copy those properties to another weld. So we can say, okay, look, actually, I'd like to click on this one here and make that the same weld. So what I've done is I've clicked on that weld here and said, make this one the same. It's not right, obviously, but I've just to show you. Or I could say, make this one the same as that weld. So once you've set these welds up, you can, by using the mini toolbar, you can click and copy those welds around the model as well. So this within here, there's some great tools and great functionality. Remember that all of this is for running down to the machines. So anything that I've done on that model will feed any sort of automatic coping robot. Just make this full screen. So we can see it. So any coping robot, the CNC layout, all this is driven from the work I just put into that Tekla model. The robotic welding, again, it feeds all the robotic welding machines and the assembly machines. And of course, anything that we do in there is always represented by the correct weld label and weld type on the drawing itself. So part welds, penetrations, all within there. One last thing to end my presentation, you can also turn on the weld graphics. So if I just quickly go back into this one here and I go into my document manager, you probably can't see this too well. I've made some changes, so let's just zoom into it. Let me just zoom in the top. You can see there, look, the actual weld graphics are shown as well. So although they're in green, the actual weld and where they go are actually shown as graphics within the model. Now, some people like to show that as a hatched pattern or a solid weld. But your choice now is that you can actually click on these parts and say, look, actually, I'd like that to be shown. So let me just make this red so you can see it. That is the actual weld in the drawing. This one here, the actual weld in the drawing. So you can see, let me just change it to red. I didn't do that properly before, red and modify that. There you can see that red is the actual weld itself. So you can show the actual weld within the drawing, and you can show the kind of pattern to represent the weld as well. Okay, I've run a little bit over time, so I'm going to hand this back to the guys now. I just want to say thank you again. It's been great to be here. I'm sorry things are a little rushed, but there we are, guys.